Okay, for this problem here, I'm just going to go down to the bottom and just do a quick review of what a transformed power function is. So if we start with a parent function of this x to the n, let's recall that the transformed version, which I'll just call g of x, can be always thought of as a times x minus h to the n power plus k. And this is the way we think of our standard transformations, and then we have to remember what these things mean here. So h is going to be the horizontal shift. Horizontal is this direction, and the sign tells you whether it goes left or right. Positive is right, negative is left. K here is going to be the vertical shift, which is up and down, and positive is going to be up, negative is going to be down. And we have A here, which is the vertical stretch factor, which is like, as we talk about the stretched Armstrong, so something like 1.5 means stretch everything in this direction by 1.5 factor. 0.5 would be kind of a shrink, cut everything in half. And then if it's negative, if it's less than 0, that would mean reflect all the over, you'd reflect it from wherever it is, mirror image it. Alright, so with that background here on how to interpret these, I'm only going to maybe do 2 of these, and then you can look up the rest on the answer key. Let's think about this one here. I'll do A. This one, all we have to, we see that A is 1/2, so there's going to be some shrinking going on. And H and K are both 0, because you can always think of this as 1/2 x minus 0 to the 4th plus 0. That's how we know that H and K are in fact 0. So I'll quick draw the parent function. X to the 4th, we know that these points are there. And then if I put 2 in, I go all the way up to 16. So it's going to actually be hard. So actually, let me draw that as a dotted line. So this is the parent function, x to the 4th. It's probably a little more boxy than that. But again, I'm not really so concerned about getting this exactly right. I just want to know that you know exactly conceptually what's going on here. So that's the parent function. Now if we shrink everything vertically by 1/2, we take all these output values and cut them down by 1/2. So 1/2 of 0 stays at 0. 1/2 of 1 comes down to here. 1/2 of 16 is still 8. So it's actually not even on this graph. But the graph itself, will be below that parent function by a factor of 0.5. And so that's really all I'm trying to make sure you get here, is that the actual function of f of x is below the parent function because of that vertical stretch factor, or vertical shrink of 0.5. And then you can check B and C out on the answer key, because the concept's going to be the same kind of a process here, but we'll take a look at this one at D. Here we see that the parent function is x squared, so I'm going to go ahead and draw that in. You know that those are there. 2 squared is 4. Negative 2 squared is 4, so I'm going to do the dotted line version again of the parent function. And now we're going to move these around. So we see that A is -1, so that's going to just be no stretching, but it's going to reflect. H we see is -1, and K is +2. So maybe just using the vertex as a reference point here, we're going to move that up 2. So we know we have to come up to this direction here. And then left 1. So this direction here. So that vertex is going to go to right here. And then we need to flip this graph. So you can see here, if I start at the vertex, I go 1 over 1 up here. I'm going to do the same thing, 1 over 1 down. Or another way to think about this is that once I've moved everything, it's like the new set of axes is right here. And now I have to do that reflection over that new set of axes. So that's right here. If you do get stuck, you can always just put a point in. Let me show you what I mean by that. If, for example, if I put x equals 0 into f of x, f of 0 is negative 1 squared plus 2. Negative 1 squared is 1. Take the opposite of that is negative 1 plus 2 equals 1, which my sketch didn't quite catch here, but so that's what that point is there. So you could always just plot in a few points if you're concerned that you didn't do it right in terms of just describing it. All right, 7 here. The key. This is just describing words how this graph here is related to the parent function. And this is an exercise really in just identifying a, h, and k and understanding what they do. Here we see that k is negative 1. H is negative 1. Don't make sure you don't get h as positive 1 there, because remember it's x minus h. So x plus 1, you'd have to rewrite that as x minus negative 1 to get it in the right form, and that's why h is negative 1 there. And then a is negative 1/2. So we can see that this is going to be reflect, because a is less than 0. It's going to be vertical compression by a factor of 1/2, so it's going to shrink stuff down like by a factor of 1/2. It's like taking your height and multiplying it by 0.5, and then we know it's going to go down 1 because k is negative 1, and it's going to go left 1 because h is negative 1.